Okay, we're going to learn about multi-digit subtraction and how to show students how to develop that algorithm. Uh, we need to have a few things well established with our students. One is that that they understand base 10 blocks and how they work, so to speak. So they've used these before; they're very comfortable with these. In particular, they have to understand the idea of trading, the idea that one stick is worth 10 units or 10 cubes, and that I can represent a number such as 23 with 2 10s and 3 1s. I can do that with that way, or I can do it with 1 10 and 13 1s, or no 10s and 23 1s. That's the idea of trading, that I can represent the same number using different types of blocks. The other thing we want to use is the base 10 mat, which is what we have here. So that's going to help guide us. We're also going to use some of these little slips of paper. But anyways, that's what we have to have established, that they have used these base 10 blocks before. So the first thing we want to do is we want to do subtraction without any kind of regrouping or trading. In old language, that would be called without borrowing. Okay? So, such as a problem like we want to do 28 minus 12. So maybe I introduce this problem in my second grade class. They don't know how to do it except to actually count and things like that. And so I'm going to ask them to represent 28 with the base 10 blocks. Now, what we don't want to do here, and this is a place that it's easy to make a mistake, is to also represent 12 on the base 10 mat, because this can actually cause some confusion. Okay, now when we were adding 28 and 12, when we were adding them, we would represent 28 and 12 on the base 10 mat, and then we go ahead and we add the objects together. This is going to cause a problem if I represent 12 on here, because now if I say 28 minus 12, take away 12, the answer is 28. And some students will see it that way. Okay? So we don't want to represent the 12 this way, because when we take it away, some students will say, oh, the answer is 28, and they'll get confused. That's where these pieces of paper come into play. So we have the 28 there, and I'm going to write down on here what I want to take away, 12, okay? And I can talk about this with my students. I could say, okay, what does 12 represent in terms of base 10 blocks? Okay, and that'd be 2 1s, 2 units, and 1 rod, or 1 10. Okay, and then what I'm going to do is I'm going to say, okay, so let's break those up. Let's just tear it and put the 2 under the 1s, and that's the number of 1s I need to take away, and the 1 in the 10s column, because that's the number of 10s I'm going to take away. So now, okay, I'd let the students go ahead and do the subtraction however they want. At first I'm going to let them do it however they want, just to become familiar with subtracting with the base 10 mat and the base 10 blocks. This isn't going to take a long time. And of course, getting used to this idea of tearing those two. So some might take away the 1 10 first, and then the 2 1s next. And then we look at the answer, ask them what's the answer, and they say 16. I write the answer down. Okay, so we could try another problem, 54, let's just say. And we want to take away, in this case, 21. So the problem is going to be 54 minus 21. Okay, so they've already done what I just said here, working freely. And now we come to the next part of this. Again, no regrouping. So then of course, they're used to it at this point. They're very good at this, at 21, because they've done several of these problems. They know they can go and do this. All right, and now I'm letting them, again, do it freely. And I'm going to, though this time, ask them how they accomplished it. Because some are going to take the 2 10s away first, and some are going to, and then the 1 1. And then some are going to do just the opposite. They're going to take the 1 1 away, and then the 2 10s. And that's the one I'm going to focus on. I'm going to say, okay, if somebody in class did it, like if Kim did that, Or if Tommy did that, I would say, let's do it Kim's way. Let's all try doing it Kim's way or Tommy's way. They took the ones away first and then the tens. Now, if nobody in the class did it, then I would just suggest that as asking, can I do it that way? Does that still work that way? And of course it does. And then let's all try it that way. Now I want them to practice that, taking away the ones first, then the tens, at least 2 or 3 times, just to get used to it. It's not, again, this isn't a big jump here for the students. And so they practice it. They take away the 1 and they take away the 2, and then we write the answer on the board. We do a few of them. And then at some point, I'm going to want to begin to show how what they're doing here can be represented here. So after they've done this, again, a couple times, just again so that they get used to it, I'd ask them, okay, 38, and we want to take away 15. So right now they're very good at this. Okay, and I say, well, let's stop now. You know, I want to do a step by step with them, because each step that they're going to do here is going to be mimicked in here. And I want them to see how it's being mimicked in here, because I want them to eventually do it just here in the abstract with the writing. Okay, so I'd say, well, so what's the first thing that we're going to do now? And they're going to say, we're going to take away 5 ones. Okay, I say, go ahead and do that and stop. Okay, so I take away the 5 ones. I say, okay, I'll stop. Where is that in here? What did you just do here? Can you show me? What are the digits here? What are the numbers here? And they say, okay, we took 5 away from 8. And then I'll say, okay, what were you left with? 3. Okay, so I'd say, so 5 from 8, or 8 minus 5 is 3. Okay, now I'm starting to give meaning to this here. Before they were just writing the answers here. Now I'm starting to see how this represents this, how it truly does represent this, and the movements here are going to be, we can do them right here. I'll say, okay, what's the next thing you want to do? Take away 110 from the tens, okay? And where would that be here? Taking away 1 from 3, 3 minus 1 is 2. Now this is very, very important, not just for them to do it here, because we want them to do it in the abstract and writing rather than here, but also it's the idea that I can break a number like 38 and 15 into parts, that I could actually start looking at it as this and this. Now that's very different. Okay, for us as adults, we're used to seeing it like that. But for these students, that doesn't necessarily make a lot of sense if you teach it completely on the board, in writing, abstractly. It makes perfect sense when you use these manipulatives. It does not make a lot of sense here. If you tell the students, okay, I'm going to show you how to subtract 15 from 38, and they write it down, and you say, okay, here's the first thing you do. You take 8 minus 5. If they're thinking, if you have a very a group of students that's still thinking about things at higher levels, not just following along with the teacher and doing what the teacher wants, but actually thinking about the math, reasoning with the math, that isn't going to make a lot of sense to them. Because they're going to look at this and they're going to say, what do you mean 8 minus 5? That isn't 8 minus 5, that's 38 minus 15. And the teacher's going to say, no, 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 just follow along. This is how you do it. Well, as soon as the teacher says that, now the students are down at the very lowest levels of Bloom's. Knowledge and comprehension, because now it's like I can't reason this thing. I'm trying to analyze it and evaluate it, the higher levels of Bloom's, and the teacher's stopping me from doing that. They're saying, no, 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 just listen and follow along, just comprehend. Okay, and that's where we don't want the students to be. And that's where definitely the Common Core doesn't want the students to be, but even as a math educator, I don't want them to be at that level. So they need to have a reason why they can break those apart like that, why you can just take the 8 away from the 38. And using a math explanation like, oh, that's place value, that doesn't make a lot of sense to even adults, let alone, here we are in 2nd grade doing this. It doesn't make a lot of sense to them, okay? And they'll say, oh, okay, it's place value, and I got to remember that for the test, but they really don't understand it, okay? However, you can see right here with these blocks how it makes perfect sense that I can take away 5 from the 8 that we had here, and then I can understand why I can take 5 away from 8 there. So as we're doing this, we are talking place value. When we say taking away 5 from 8 and 1 from the 3 here, we are talking place value in informal terms. Okay, we're taking away the 1s and the 10s, the 1s place and the 10s place. Okay, we're understanding at a conceptual level. Okay, so this problem here that we just finished, it's the first one where they're starting to see how this is imitating this, what's going on in the real world, how the rules here are coming out of the real world. The real world is defining the rules. Mathematicians aren't. Mathematicians are just identifying them and then just representing them with these symbols here and with our movements here. And that's really what all math is. You have K-12 math, that's really what it all is. And if students can believe that, then they can start understanding and reasoning mathematically. Okay, so we would try maybe 2 or 3 where, again, at this stage, where I would have the students take any kind of problem. Okay, we'd represent the 27, we have the 13 on there. They'd take away the 3 from the 7 first, and then I'd have them stop. And then I'd say, where is that here? And they'd say, it's right here. Okay, so 7 minus 3 is 4. Does that agree with this here? Yep, see how they're analyzing and evaluating? And then I come over, what's the next thing you do here? Well, I got to take 1 10 away from the 2 10s. Okay, do that. Where is that here? Okay, does this agree? 2 minus 1, and we have 1 left? Yes. Okay, do we have 14 left? Yes. Okay, so now I'm starting to say, okay, what we do here, we do here. And since I understand this here, I can use this to guide me with this, because that's where we're going to go with this. Okay, at some point where we've done several of these, just step by step, just like we did 38 minus 15 and 27 minus 13, I'm going to ask them, I'm going to challenge them, could they do a problem like 45 minus 21, but do it in writing first. See if they can do it here first, and then go and check it with the manipulatives. Okay, and what you should hear if the students are talking out loud, or if you walk up to them as they're working on this and say, why are you doing that? Okay, you should hear them talking in terms of the base 10 blocks. They would be looking at this, and they would, if they say 5 take away 1 is 4, and you would say, why can't you do that? And then what they're going to do is they're going to refer to this very rich, very deep experience here with the base 10 blocks, and they're going to say, well, that's like if you had 5 of the little cubes there, and then we tore the paper and you had the 1, and so you had to take away 1 from the 5 cubes and 4. That's what's guiding them. That very powerful, memorable experience is guiding this here. This isn't a set of memorized rules now. It makes sense to them. Okay? So they would again solve the problem, check it with the base 10 blocks, do maybe another 1 or 2. If they make a mistake, they have a good chance of catching it themselves. Okay? For example, if they do something wrong here, and then when they go and they check it here, they're going to say, well, hey, that doesn't work. You see, I'm making them independent learners, making them, I'm empowering them. Okay, that, oh, if I make a mistake, I can figure it out because all of math makes sense. This makes sense to me. So if I make a mistake, I'll figure it out up here with the thing I really understand, and then I'll translate those ideas back here. Okay, so that's the power of this way of teaching. Okay, we're making them independent learners rather than dependent and creating helpless learners. Okay, so that's the first part. We could easily expand this into hundreds, 345 minus 132, for example. And I could go through the exact same thing with the students. Have them put 300, $45, and then I take the paper. Right, 132, and tear it into three parts. And again, direct them to begin over here. And then once they begin over here, imitate here. So we take away 2. I'm left with 3. Where is that over here? 2 from 5 is 3. Okay, now I'm starting to see I can do the 1s first. 3 from the 4. There's the 3 from the 4. And of course the 1 from the 2. Okay. So same type of procedure, except we're just adding the hundreds to it. Okay, no regrouping in that set. Now we want to move to where we're going to regroup or trades, or in a lot of our language, that would be doing the borrowing. At this phase, we want to remind students, because when you do the regrouping or the borrowing, which is really incorrect terminology, making the trades, we really want the students to go back and review like how they can represent 35, because that's the key when we borrow or regroup. Okay, so that's 35. I could say, is there another way I could represent 35? And yeah, I could take away 1 10 and put in 10 ones. So I could have 2 10s and 15 ones. Okay, or I could take away another 10, have 1 10 and 25 ones, or 35 ones. Okay, that's very important to see that I can represent these in a lot of different ways, these numbers in a lot of different ways. Okay, so now we're going to do a problem like 35 minus 17. And so the students now, they know how to set this one up. Okay, and now we have a problem. We have an issue. I need to take away, what's the issue? I'd ask the students, what's the problem? Well, I don't have 7 to take away. Okay, as a class, I want to discuss this. I don't have 7 to take away, and there's my 35 up there. Could I represent 35 in another way, where I could have at least 7 little cubes to take away. Now, a lot of students, it depends what they want to do. Some will just take one of these and make it into 10 ones. Some will take 2 of these and make it into 20 ones, and that's fine. 3 of these and make it into 30 ones and put all the ones over here. Okay? All those are valid. Okay, so at this point, I just want them to solve the problem however they want. So if they would take like all 30, I'm not going to do this, but if they would take all 30 and put all the 30 over here with the 5, and then take away the 7. Okay, so let's say they did that, and then now they got all these gone here, and the 7, of course, is gone. Now they don't have any 10s. I'd say, well, how can we get some 10s in there? Then they'd take those and trade them back. Okay. I'd let them do that at least 2 times. I'd let them do it however they want. And I would discuss with them, how do they do it? Maybe everybody's taking all the 10s and turning them into 1s. Maybe somebody's taking only 1 10 and turning into 1s, or 2 10s and turning them into 1s, and so on. And we'll discuss all of those. And then I would want to say, well, what would be how many 10s would I have to take for this problem here? How many, like Billy, you took all 3 of them, and Jeremy, you only took 1 of them, and Kim, you took 2 of them. Which of those is the easiest, is the quickest? What's the least number of 10s I need to take? Of course, the answer is 1. Okay, so 2 or 3 problems like that, talking about that, the students start to come up with, and again, it's the students that are coming up with this, they start to recognize that, geez, I really only need to take 1 of these and trade them, and it's just easier than taking 3, and depending on the problem, I could have 52 as a problem here, and I got to take all 5, and I don't even necessarily have enough units, ones, to make the trade, and so on. We want to get them the idea that they just want to take 1 10. Because that's the quickest way, and and they're going to want to do that too. Because who wants to trade in? If I had 7 of these, who wants to trade in those for 70? It's just a lot of work, and then have to trade them all back to get enough in the 10s column. Okay, so let's say we're at that point now. where as a class we agree we're just going to take 1 10, just the least number of tens to make this work. Okay, so in this case here, let's go back and let's just do a problem similar, and we'll just say it's 35 minus 17. So now this is like our fourth or fifth problem. And so now we're on a problem. We'll just make it different here, just to so we've done that. We've kind of talked as a class that's what we're going to do. We're just going to take the least number because it's easier. So now we start at 4217, and now we're going to start making the transition, because at this point we've been solving the problem here with manipulatives and just writing the answer here. We have not been doing any manipulation here at all. We just have been representing the problem, taking away what we had to, making the trades up here, and then writing the answer. Okay, so now we're going to give meaning to this, so we don't have to even use these things. We're going to make that transfer. We're going to translate those actions here to the work here. So let's say we're at this and say, okay, what do we do? And the class says, well, we trade in 1 10 for 10 ones. Okay. All right, there we've got it. Okay, now I would say stop. Okay, at this point stop, because now every single movement they do up here, I want to do it down here and let them see and start seeing how I'm representing their movements down here, because I want them eventually to do it all here in the abstract. So, okay, where is that here? What did you do here? Okay, well, we took one of the tens. Which of the tens? This 10 here? No, it was from here. Oh, okay, from here. And what'd you do? Okay, I took one of the tens and I made them into 10 ones. Okay, so I took one of these 4 tens and I'm left with 3 of them, right? And they can see right on there. And if I have this in a document camera, they can see, yeah. So there were 4, now there's 3. Yeah, okay, so we took one away. Then what did we do with it? Well, we took the 10 ones and put them over here. Okay, so we put the 10 with the 2, which gave us a total of 12. Okay? All right, now what's the next step? And they say, okay, we take 7 away. Okay, so I'll go ahead and do that. So take away 7 away. I say, where is that up here? And I say, oh, it's right here. It's the 12, take away 7 is 5. Okay, you see I'm giving meaning to this. Okay, now what do you do? Okay, well, now we can take away 1 10 from the 3 tens. Where's that up here? Okay, it's right here. Okay, so go ahead and do that. And they do that. Where is that here? It's 3 minus 1 is 2. Okay, I would want them to do this at least 2 or 3 times before it comes a time for us to try and writing first and then check it with the manipulatives. Okay, so we do it again. We go as a class. We go step by step, just like I did here, for 2 or 3 more problems. They really understand. They really have to understand the situation here, because these memories here are going to drive them here. And then I'm going to give them something in writing. Okay, I'm going to say, okay, wait, don't represent these yet. Try it here first. See if you can figure it out here first, and then check it with the manipulatives. And again, if I'm walking around, if anybody's talking out loud what they're doing, or if I'm asking them, why are you doing that? They're probably going to talk in terms of the base 10 blocks, which means they really understand it. Okay, it's not a memorized procedure, but this is what's driving them. So they might say here, okay, 6 from 4, and that means I have 4 of the little things. I need 6, and I don't have 6 here, so I got to come over here and take one of the 10s and make it 10 plus 4 is 14. Okay, now if they make a mistake, and some will, like for example, some might come over here in writing, and they're doing the writing first, and might say, oh, 6 minus 4 is 2. Okay, and then 5 minus 2 is 3. All right, well, I'm empowering them. I've empowered them because they understand how to do this. They're doing it incorrectly right now, but they understand what it means. They understand the concept. And then when they go to check it, and of course they write the 26 down. And and they say, okay, I got to take 6 from there, I got to make a trade, and so on, they're going to find the answer doesn't agree. And now I'm going to challenge them and say, well, what happened here? Which is right? Do you think this one's right or this one's right? And I would say, go set it up again, after, because they've already finished doing all this. Go set it up again and go step by step and see if you can find your mistake. I want to challenge them. I want to give them the confidence to know that they can figure this out. And there's a good chance they're going to be able to figure it out. And they're going to say, oh, yeah, I didn't have enough. And it's so much more powerful than me telling them, saying, here's what you did wrong, because now they become dependent on me. And they have less confidence in their own abilities. Okay? But by me challenging them, and maybe even by step saying, okay, what's the first thing you do here? Where would that be right here? Okay? And then what did you do here? Okay, now it's like, oh, and then they start to understand it. But they understand it at a conceptual level. Unlike most of us adults, the way we learned it, we just learned it as a procedure. Oh, I just did it in the wrong order. Oh, I just did it the wrong way. They're going to say, no, that doesn't make sense. And then you can even ask them, well, which one makes sense? Do you know which one is the right answer? Is there any way you can check this? Okay, and so on. So that's what that's kind of the whole reason why we're doing this. We're making them independent thinkers. They understand the concept. So you can see here we are, and again, you could do this with the hundreds too. You could bring in the hundreds and have the regrouping, whether it's only regrouping with ones, like 372 minus 125. Here we'd only be regrouping the ones, not the tens. You could also have it where you're regrouping you have to regroup for the ones and the tens, but you can see it's the same type of procedure. Okay, so this way of teaching, what we're doing is we are hitting the higher levels of Bloom's. They're analyzing, they're evaluating. You can see that they're seeing patterns in the work, that they understand the concept, that the concept drives what they do on paper. Okay, and again, we're beginning in the concrete and we're moving to the abstract, where the abstract imitates what's going on in the concrete world. And that's what K-12 math is all about.